Okay, with the previous class we completed first unit. First unit is elementary treatment of metal cutting theory. Okay, in this class we will discuss about unit 2. Unit 2 consists of lathe machines. Okay, in lathe machines we have different types of lathe machines and specifications of lathe, main working principle of lathes, next tool holding devices and work holding devices, different types of operations on lathe. Okay, these are all the topics included in unit 2. Unit 2 lathe machines. Okay, I am sharing my PPT to you. Students, my PPT is visible to you? Say yes or no?
కనిపిస్తుంది సార్.
Okay, ma. Okay. Unit 2 name is lathe machines. First of all, coming to definition of lathe, we already know about that. Lathe is a machine which removes the metal from workpiece. Next, lathe is very important machine tool in the metal working industry. The main working principle or function of lathe is, in this the workpiece is rotating and the tool is fixed at stationary point. Remember that the tool is fixed and the workpiece is rotating. This is the main function and working principle of lathe. Next, the feed will be given. The cutting tool is feed into the workpiece. Okay, in this we are giving feed by means of workpiece which rotates about its own axis. In this we are giving feed by using of feed rod to the direction of cutting tool. Next, it is also known as mother or father of entire tool family. Main the definition of lathe is removing excess or material from the metal or workpiece. Next, previously I was told you about that the function of lathe or principle of lathe is remove excess material in the form of chips. Here the main function of lathe is the rotating workpiece against a stationary cutting tool. In this, that means the tool is fixed at stationary point at headstock point, but the workpiece is revolving. It is the main function of lathe. Coming to industrial revolution demanded, that means why we are preferring lathe machines in industrial areas, because of more productions. By using lathe machines, in olden days we are preferring conventional or traditional machines here. In that point, for finishing or manufacturing the products, it taking more long time to produce the parts comparing to old traditional methods and advanced lathe machines. In these days we are using advanced lathe machines, namely CNC machines, CNC lathe machines, computer numerical control machines. By using CNC machines, the working process, that means producing the parts, taking shortest time. Lead time is very less because of using lathe machines, advanced lathe machines. More precisions. Precision means accuracy. Accuracy and specifications, dimensions. Specifications means dimension of geometry. He is very accurate by using lathe machines. Changes in manufacturing process, that means manufacturing process is nothing but by transforming traditional to latest methods. lead to the development of high speeds. In olden days, we are preferring engine lathes, etc. types of lathes are there, but speeds of spindle is very slow compared to old machines to the advanced machines. In advanced machines, speed of the spindle is very high. Okay, but the reason we are preferring speed lathes in industrial areas. Special purpose lathes are semi lathes and semi automatic lathes, single spindle and multi spindle. It will be discussed in next slides. Next, coming to main parts of lathe. Lathe machine is also known as center lathe. Okay, it has two centers between which the job can be held at and rotated. The two centers are, one is the headstock and the second one is the tailstock. In two centers, one is headstock is also named as live center. Live means it is also whenever it rotates, okay, it is also always rotating. So I am calling headstock is a live center. Next, tailstock. Tailstock, I am calling tailstock as a dead center. Why? Because I am calling tailstock is a dead center, because of tailstock is a just a support. Okay, it is just a support to fixing the tool or support. Next, carriage. Carriage consists of parts like tool post, cross slide and compound rush. Here I am showing the main parts of lathe machines. Okay, in this, first of all, I am talking about bed. In right side, upon the box, I am showing bed here. Bed is a just support for all the components like feed rod and lead screw, etc. Next, I am talking about headstock and tailstock. Here I am showing headstock. Okay, in left side, the revolving part is headstock. It consists of jaws. Jaws are inside of chuck. Chuck is a device used to hold the workpiece. Okay, chucks are two types: 3-jaw chuck and 4-jaw chuck. 4-jaw chuck is independent chuck or individual chuck. But coming to 3-jaw chuck, it is a dependent chuck. When we are rotating or revolving the one jaw, automatically the remaining jaws are moved by means of based on one jaw. Coming to 4-jaw chuck, we are rotating one jaw, remaining are stationaries. This is the difference between 3-jaw and 4-jaw chuck. Next, I am showing tailstock to you. Tailstock is, it is placed on bed here. The right sided part is tailstock. It is also just support to the component. In this, I am placing a tool. It is always at a stationary point, but it is used in some operations like drilling and reaming process. Next, coming to, after that, headstock and tailstock, carriage. The center part is carriage. Carriage consists of cross slide and compound rest. Cross slide will be moving in reciprocating direction like upward and downward direction. Compound rest. Compound rest is used for also moving forward to backward direction. Next, here I am showing apron. Apron is it is also a box, consists of gears here. Different types of gears aligned in this carriage box. Next, In this, we have lead screw and feed rod. The center rod is called as feed rod, and the above feed rod we have lead screw. Feed rod and lead screws are just okay. Feed rod here, feed rod and lead screws are powered by gear system here. Next, spindle. Spindle is used in headstock for changing different various speeds. Next, in this speed adjuster here, we want to adjust the speeds by changing the gears, the speed lever, changing lever here. Next, feed selector here. Feed selector is used for changing the feed in left side direction or right side direction. Chip plane or chip pan. Chip pan is used while we are in operation. For example, I am taking step turning process. In step turning, I am taking a steel rod, MGM rod. While I am in facing operation or step turning operation, after removing the excess material, the chips are fell on the chip pan. This is used for dust coverage or excess chip coverage. It is named as chip pan. Next, hand wheel of tailstock to move in forward direction or backward direction. Next, these are all the main parts of lathe machine. But the main components of lathe machines are two centers, headstock and tailstock. Next, carriage part. Carriage consists of tool post. In tool post, we are setting the tool and giving the feed by using feed rod or hand wheel. Okay. After description of and explain all lathe components, we are moving into theory of lathe machine. These are all the topics we are discussed in lathe machine: headstock, next tailstock, feed rod and lead screw. After that, working principle of lathe. The main working principle of lathe, in this, the workpiece is held at in between two centers. One is headstock and next one is tailstock. We are giving the feed by means of tool is placed at perpendicular to the workpiece. The main working principle is when the workpiece is revolving or rotating, but the tool is placed at stationary point. This is the working principle of lathe or function of lathe. Next, working principle of lathe. In this, if the tool is placed at parallel to the workpiece, here I am showing the picture about parallel setting of tool facing to the workpiece. Here, the tool moves parallel to the workpiece. cylindrical surfaces, but means chamfer or cylindrical surfaces are produced. Next, in previous slide, we are setting the tool at parallel position. When tool set at parallel position, cylindrical surfaces or cylindrical formations are produced, but the tool fixed at an angle of inclination. The tool moves inclined to the axis, it produces taper surfaces. It is also known as taper turning. Taper turning we will discuss in detail in next slide. There is also theory about working principle of lathe. These are all the topics we discussed in previous slides. Okay, I am moving into next slide. Next, coming to specifications of lathes. These are all the main specifications. Specifications means heights, depth, etc. Here, first of all, I am discussing about height of centers. Height of centers means type of bed. Which type of bed we are using, straight or semi-gap or gap. These are the different types of beds here. The main types of beds are we are using straight type. Next, center distance between two centers. Next, swing over bed, swing over cross slide, swing in gap. Swing means just a slight movement. Cross slide it is placed at a position of carriage. Next, gap in front of faceplate. Spindle speed range. Spindle speed range means spindle nose, spindle bore, taper nose. Spindle it is placed in inside of headstock. Next, metric thread pitches, lead screw pitch. These are all the main specifications we have to follow for performing various operations on lathe machines. Cross slide travel, top slide travel, tool sections, shipping dimensions, motor horsepower from this range to this range. These are all the dimensions and speeds we will discuss in lathe machines. Okay. Next, coming to types of lathes. We have different types of lathe machines are there. First of all, I am discussing about engine lathe. Engine lathe is a old type or traditional lathe. Engine lathes are widely used in workshops or industries, but comparing to speed lathes, the speed of the spindle is very slow. Okay. Next, we are moving into bench lathe. Bench lathe is a portable lathe. Portable means because of volume. Engine lathe occupies more volume here, but compared to engine lathe, bench lathe takes less volume. It is also called as small lathe. Okay, it is used for making of small precision and preferring for light jobs. Next, speed lathe. The answer for speed lathe or name as itself, speed lathe, because of the very high speed of headstock spindle. Okay, it consists of headstock, tailstock, tool post. In this speed lathe, it has no gearbox. Okay, no engaging of gears, automatic gears are here. These are used for wood turning and metal spinning operations. Next, tool room lathe and special purpose lathes. Tool room is similar to engine lathe, but it is designed for accuracies. It is used for dies, tools, jigs, etc. So because of that, I am calling it is a tool room lathe. Next, special purpose lathes are also there in types of lathe. They are namely gap lathe, instrumental lathe, facing lathe, floor turning and heavy duty lathe. But we are discussing more about engine lathe, bench lathe and speed lathe. automatic lathe. Automatic lathe is nothing but in this workpiece is automatically feed. Okay, I'm explain about automatic lathe here. In this we are not giving in manual feeding here. The workpiece is placed at jaws of check, that means headstock position. In headstock, tool is placed at tool post. When we are set an automatic feed here, the removing of workpiece or the removing of metal or excess material from the workpiece will be done by using automatic feed here. By giving automatic feed, the lead screw is moving at an axis of direction facing to the workpiece. Next, turret lathe. Turret lathe is similar to the engine lathe. Because of why I am calling similar to engine lathe, but here I am changing the tailstock position. Instead of tailstock, here I am replacing a turret slide. Turret slide is nothing but cylindrical or hexagonal type. Okay, instead of tailstock, I am fixing cylindrical or hexagonal here. Okay. Next, capstan lathe. Capstan is similar to turret lathe, but in this turret is not fixed. Turret is also moving in auxiliary position, used for fast production of small parts. Operating condition. In this, I am showing the directions of feed and tool moving direction. I am representing here by using of arrows here. First of all, the tool is placed at tool post and workpiece is held at headstock by means of jaws and check. Next, when we are giving the feed in left side direction, that means facing the workpiece. Facing the workpiece, we are giving the feed. Next, the tool is moving in the direction of workpiece for reciprocating direction, that means forward and backward direction. When we are giving here, I am showing the process of step turning process. Tool is moving facing the workpiece. When we are giving the depth of cut by using of hand wheel here, this is the operating condition of lathe. Lathe operations. Here I am discussing about different types of lathe machines here. Sorry. Here I am discussing lathe operations, not lathe machines. Lathe operations. We are performing, these are all the operations and more operations are there in conducted on lathe machine. Here I am discussing some of the operations here of lathe machines by using of lathe machines. First of all, turning, facing, boring, drilling, reaming, threading and knurling. First of all, what is turning? For turning process, we are using different type of tool for turning. In turning, there are two types of turnings are there. One is step turning and second one is the taper turning. In step turning, we are removing the flat surfaces by means, first of all, I am taking steel MGM rod. After that, it have outer dia. Then I calculate the dimension for required removing of step. Okay. In this, the tool is placed perpendicular to the workpiece, giving feed by using of hand wheel for removing turning, step turning. Coming to taper turning, for taper turning, I am fixing the compound rest at an angle of alpha. That means tan alpha equal to d1 minus d2 by 2l. d1 is the outer dia and d2 is the required dimension. Okay. Previously, I was told you about that. d1 is 100 mm. I want to make it as 50 mm by using of taper. Taper is nothing but the tool is fixed at an angle, that means inclination to the workpiece. Next, facing operation. Facing is nothing but removing of material and producing flat surfaces by using of lathe machine. Next, boring. We are also know about that already. Boring process is that enlarging a hole. Engine consists of piston and bore. For boring operation, we are enlarging or extending the sizes of volume of bore. Next, drilling process. Drilling is nothing but making holes or producing a hole on the workpiece. Next, reaming. Reaming is similar to drilling process, but after drilling process, finishing is done by reaming process. Threading. Threading consists of internal and external threads. For threading, we are preferring different type of tool in tool post. Knurling is also same to threading, but it differs. Threading means internal or external threads, but coming to knurling process, to produce regularly shaped roughness on the workpiece. The figure of knurling I will show in next slide. Here, these are the different types of operations performed by using of lathe machine. First of all, I am talking about straight turning. Straight turning means here straight turning or step turning. Here the tool fixed at perpendicular position to the workpiece. In taper turning, I am fixing the tool at inclination to the workpiece. Next, profiling. Profiling is also process of removing the metal from the workpiece. Turning, facing is nothing but producing flat surfaces. Face grooving. Next, cutting with a form tool. These are all the operations performed on lathe machine. Drilling means making of holes. Cutting process, cutting. Next, threading. This is the picture of threading, internal or external thread. Here I am showing about external thread. Knurling process. This is a picture about knurling process. For knurling, I am using this type of tool here. Okay. For threading, automatic feed or a manual feed are given for producing threads on given workpiece. Next, processes. Turning process. For turning process, we are using turning tool here. Okay, this is the picture for turning process. Excess material is removed to reduce diameter. Turning tool is used for performing the turning operation by using of turning tool. Workpiece is held on check. Okay, these are all the similar for all operations. Facing is nothing but producing a flat surface or reducing lengths. This is the picture for facing operations. For facing operations, I am using same turning tool here, but feed will be given in direction perpendicular to the workpiece axis. Okay, depth of cut will be direction parallel to the workpiece. Knurling. For knurling process, I am showing previously to you. I am using different type of knurling tool here, producing rough surfaces. Material removal rate is 0. But why MRR is 0 in knurling process? Because of in this we are not removing any material here. We are only performing or producing knurling shape on given workpiece. Okay, this is the picture of knurling process. Knurling means diamond shapes performed on or diamond shapes produced on given workpiece. Grooving is a process produced on workpiece. Here I am using groove shape type. Groove is nothing but U groove or V groove. Okay, here I am showing picture about grooving operation. Cone type tool is used here for producing grooving operation. Feeding operation tool, here I am using form tool. This is all are the operations are similar to lathe operation. Next, parting. Cutting workpiece into two. Parting means we already know about that. Parting is a process of splitting one workpiece into two workpieces. Similar to grooving process. Okay, here I am using parting tool. Coolant will be used here. That means coolant oils used here. This is the operation for parting. Parting tool used here in this inclined type, that means tapered, not inclined type. Tapered type tool is used placed at tool post. Because of using parting tool, the workpiece is splitting into two types. Chamfering. Chamfering is nothing but making the workpiece at certain dimensions. That means reducing the areas at corners by using chamfering tools. In chamfering, we placing the tool at 45 degrees at an inclination to the workpiece. Why we are performing the chamfering operation on workpiece? Because of avoiding sharp edges on workpieces. Okay, improve aesthetics and assembly is easy. Because of sharp edges, the assemblage is very difficult. By removing the sharp edges and corners, assembling is very easy in industries and automobiles, etc. Drilling process. The drilling process is similar to where other operations, but here the cutting tool is fixed at tailstock. Okay, not placing at tool post. Here I am placing the cutting tool inside of tailstock. By moving the tailstock with the axis of workpiece, the drilling operation can be done by using of tailstock. The difference between other operations to the drilling is nothing but in other operations the tool is placed at tool post. Compared to other operations, in drilling operation we are fixing the tool at tailstock. By removing the tailstock in forward direction facing the workpiece, drilling operations can be performed on given workpiece. Taper turning. Previously I am discussed about this. Taper turning means reducing the dia of given steel rod and anything. D1 is first of all taken rod dimension, that means D1 is outer dia. D2 is nothing but required dimension. First of all, for example, I am taking D1 is 100 mm. The required dimension will be 50 mm. For that, D1 is 100 minus D2 is 50 mm by 2. I am taking L is 200. Then alpha will be calculated. This alpha will be set on carriage for taper turning operations. This is the taper turning operation. In taper turning, we are using form tool here. Methods of taper turning: swiveling of compound rest, taper turning attachment, simultaneous longitudinal and cross feeds. These are all the topics we will discuss in later.